Hello everyone. Today we want to talk about 8.1 basic approaches. Basically, it is a review of what you have learned in Calculus 1. You can see that most of the problems have U substitutions involved. Okay, so let's take a look at example 1. You want to integrate 1 over e to the x plus e to the negative x with respect to x. So notice that right here you have e to the negative x, and this negative exponent means it's the reciprocal of e to the x. That means I can rewrite it as 1 over e to the x plus 1 over e to the x dx. Now, you might want to say, hey, I heard you previous mention that we want to use U substitution. So if we want to use U substitution, and a natural setup should be U equals e to x, right? Because you can see that we have e to x right here. But notice that if you want to set U equals e to x, then your du, okay, so let me write this down. If U equals e to x, then du will be e to x dx. Okay, so that means you need to have an e to x on top combined with dx to make it a du. Okay, however, right here you don't have e to the x on top. Okay, so right here we want you to do a little bit more work before we use U substitution. And right here we want to multiply by 1. And you might be wondering, but if you multiply by 1, that doesn't change anything, right? Yes, that's the point. I don't want to change the integral, okay, because I want to evaluate this integral. I don't want to evaluate something else, okay? But I do want to change what it looks like, okay? So I can write 1 as e to the x over e to the x. So notice that this guy right here is 1, okay? So I multiply by 1, I didn't change anything. However, I will change what it looks like, okay? So right here, you can see that 1 times e to x is e to x. And since we have a sum multiplied by a number, we want to distribute this into the sum, right? So this will become e to x squared. And 1 over e to x times e to x is just 1. Okay, so you can see that by using this idea, I multiply by 1, and I rewrite 1 as e to x over e to x. I didn't change the value, but I did change what it looks like. And furthermore, I have e to x dx right here, and I can make it my du. And right here, e to x is my u. So my integral will become e to x dx is my du. So I have 1 du. Okay, and I have e to x, which is u, e to x squared. So I have u squared plus 1. Okay, so you have the integral of 1 over u squared plus 1. Now from Calc 1, we know that the integral of 1 over u squared plus 1 is arctangent of u. We have arctangent of u. And don't forget, this is an indefinite integral. Okay, indefinite integral, that means you don't have upper bound or lower bound. Okay, indefinite integral, so you need a plus c. Because we want to find the most general antiderivative. Okay, this represents a family of antiderivatives. Okay, so we need a plus c right here. Okay. Now, if you forget that the integral of 1 over u squared plus 1 is arctangent of u, please make sure you go back and review, because Calc 1 is the prerequisites of this course. We will have a lot of integrations like this. Okay. Now, notice that this is not your final answer, because you started with an integral with respect to x. That means your answer should be in terms of x. So finally, we wanted to change u back. Okay, so this is arctangent of u, and my u is e to the x, so I have arctangent of e to the x plus c. Okay. Next, let's take a look at example 2. So I want to integrate. Okay, I want to integrate x cubed over square root of x squared plus 1. Okay, and the problem gives you the hint. We want to use the substitution where u equals x squared plus 1. Okay, x squared plus 1. Okay, so let's follow the instruction. So my u is x squared plus 1. Then my du will become 2x dx. Okay, so that means right here we will be able to, oh wait a second, we have x cubed on top. Okay, so let's say we have a different problem. Let's say we have x over square root of x squared plus 1. Okay, we have this problem instead of this one. Okay, a new problem. Then x dx can be written as 1/2 du. Then I will be able to replace this x dx by 1/2 du. And here this is just u. So I can take care of everything. Okay. However, right here I have x cubed on top. Okay, I have x cubed on top. Okay, but don't worry, because we can make a simple change to this problem, and then we will still be able to use this u substitution. Okay, so let's write down here. We have x cubed square root of x squared plus 1 dx. And previously we say that if we have a new problem, okay, and the numerator is x, then we will be able to use u sub. Okay, so let's just factor out x. Okay, because you know, we need an x dx in order to create a du. Okay, so that x is essential. You need that x. If you don't have that x, you cannot make this 1/2 du. Okay, so that's why I take one x out. Okay, and then this x dx is my 1/2 du. And this x squared plus 1 under the radical, this is my u. Okay, now in the past, a lot of students had a very bad habit. They will just write x squared times 1/2 du over square of u. Okay, this is not correct. You cannot put x and the u in the same integral at the same time. Okay, it's either an integral with respect to x only, or an integral with respect to u only. Okay, you cannot have x here and the u there. No, you cannot have this. Okay, so that means we need to figure out a way to change x squared. Okay, to change x squared. And then you notice that this is your setup. Your u is x squared plus 1. And we do have an x squared right here. So let's try to solve for x squared. Okay, so know that right here, x squared is u minus 1. Okay, u minus 1. So that means, okay, let me use green. That means x squared right here can be replaced by u minus 1. Okay, so I will have a new integral, and this time I don't have any x anymore. Okay, I only have u's. So I have u minus 1 times 1/2 du over square root of u. Okay, square root of u. So I want to choose u minus 1 right here, right? U minus 1 square root of u 1/2. Okay, I want you to choose B. Okay, so the key point for this problem is that you take the derivative of u, and then you need, remember, you need x dx. Okay, you need x dx to create your du. Okay, so you have to take one x out and combine with this dx. You want to reserve this x because you want it to be your du. Okay, and then whatever left, okay, you cannot just copy x squared. You need to find a way to change it in terms of u. Okay, in terms of u. Okay, so next, let's take a look at example 3. We want to evaluate this integral. 2x minus 1 over 1 plus 4x squared. Okay, now previously I mentioned that most of the problems right here, you want to use u substitution. Okay, so if you want to use u substitution, the natural choice for your u should be 1 plus 4x squared, right? 1 plus 4x squared. Okay, and if you let u be 1 plus 4x squared, then your du will be 8x dx. And then you can take care of 2x, but you cannot take care of that one. Okay, because there's no x right here. There's no x right here. You cannot take care of that. Okay, so the key point for this problem is to split up fractions. Okay, so we have 2x minus 1 over 1 plus 4x squared. I want to write it as 2x over 1 plus 4x squared dx minus the integral of 1 over 1 plus 4x squared. Okay, so I will split up the fractions. Now for this integral, for the first integral, I just use u sub. So my u is 1 plus 4x squared. Then the u should be 8x dx. Now since I have 2x dx right here, so I divide both sides by 4. So 1 over 4 du is 2x dx. Okay, 2x dx. So that means my 2x over 1 plus 4x squared right here, my I thought I changed to orange. My 2x dx is my 1 over 4 du. And my 1 plus 4x squared, the whole thing, is my u. Okay, so you can see that I take care of everything. And then this becomes 1 over 4, the integral of 1 over u du. Okay, 1 over 4. 1 over 4 is a constant, you can take it out, 1 over 4, and you have 1 over u du. Okay, so we will be able to integrate that later, okay, because it's become really easy. Okay, I'll give you like 10 seconds to think, to recall what an antiderivative is. Now for the second integral, okay, for the second integral right here, if you still use u equals 1 plus 4x squared, and then your du will be ax dx, and you need an x dx to create a du, but you don't have any x on top. Okay, so that means this is not the right choice. Okay, now think of this. The reason you have an x dx is because your u is quadratic, right? Because after you take the derivative, you still have 1x right there. This x is not, this x does not disappear. It's still right there. That is because your u is quadratic. Okay, but now our numerator is a constant. So that means after taking the derivative, I should have a constant. I cannot have x. So that means your u needs to be linear. Okay, your u needs to be linear. Okay, so right here we will need to rewrite this as 1 over 1 plus 2x quantity squared. And then I will let u be 2x. Okay, remember you want a linear. Okay, and then when you take the derivative, it will be 2 times dx. You can see that we don't have x anymore. Okay, remember if your u is quadratic, then your derivative du is linear. Okay, and right here we know we don't have x on top. That means our derivative must be a constant. That means your u must be linear. Okay, so right here 1/2 du is your dx. Okay, so this guy right here, this dx, 1 dx, okay, dx is 1/2 du, and this 2x, okay, in the parentheses is, oh well, since we use u here, yeah, let's use a different variable. Otherwise, it's a little bit confusing. I'm sorry about that. I didn't pay attention on this one. Okay, I'm sorry. So let's use a different variable. Okay, let's use w. Okay, so w equals 2x, then dw equals 2dx. Okay, so that means 1/2 dw equals dx. So dx is 1/2 dw, and this 2x is your w. So this will become 1/2. Okay, 1/2 is a constant. Take it out. 1/2 1 over 1 plus w squared dw. Okay, 1/2 1 over 1 1/2 1 over 1 plus w squared dw. Okay, so therefore we will have this guy right here is 1 over 4, right? This guy, the first integral, is 1 over 4, the integral of 1 over u, minus, okay, minus the second integral, and the second integral is right here, 1/2 the integral of 1 over 1 plus w squared. Okay, we might not have enough space, so please bear with me a little bit. Okay, so what is the integral of 1 over u? It's natural log of absolute value of u. Okay, and what is the integral of 1 over 1 plus w squared? It's arctangent of w. And since this is an indefinite integral, that means you need to put a c. Okay, you need to put a c. Okay, and remember, this is not your final answer because you started with an integral with respect to x. Your answer should be in terms of x. Okay, so right here, this is 1 over 4 natural log of u. U is 1 plus 4x squared. And notice that 1 plus 4x squared is always positive. Okay, no matter what x you plug in, 1 plus 4x squared is always positive. That means we can get rid of the absolute value sign. Okay, so 1 plus 4x squared. Okay, if you forget to drop the absolute value signs, that's not a big deal. That's okay. Okay, but you have to know that 1 plus 4x squared is always positive. Okay, minus 1/2 arctangent of w. W is 2x. Arctangent 2x. Okay, and finally plus c. Plus c. Okay, let's take a look at example 4. A u substitution will be used to evaluate the integral of 1 over x squared plus 2x plus 10. Which u substitution is appropriate to use? Okay, now you can see that this problem, okay, is kind of related to the previous one. Okay, but you might be wondering, wait, this problem I know I have to split up fractions, but there's nothing to split up. Okay, that's true, but what I'm talking about is the u sub we're using here for the blue part and for the green part. Okay, so let's make a quick review again. You notice that right here, if your u is quadratic, then your du will be linear, and that x dx is what we need. So that's why this is a good u substitution. And this same u cannot be used right here. because you don't have x on top. So that means your derivative is a constant. Okay, that means your u sub, okay, in this case your w must be linear. Okay, so let's take a look at this. If your u is quadratic, then your du will be linear. So that means you need an x on top. But do you have x on top? No. So that means we don't choose A, we don't choose B, because they will be wrong, right? Because you can try to set up u equals, oh, what's going on? Okay. So you can set up u equals x squared plus 2x plus 10, and your du will be 2x plus 2. You don't have 2x plus 2 on top, and you will never get rid of 2x plus 2. Right? Similarly, here du will be 2x. You don't have x on top. So that's why we don't choose A, we don't choose B. Okay? Then we will need to choose u to be linear because your derivative is a constant. So see here, you have 1 dx. Your derivative is a constant. Okay? So which one do we need to choose? And we will need something from your high school. Okay? And you probably hear this a lot. I always say we need something from Calc 1, we need something from your high school, we need something from your, for example, pre-calculus. Okay, this is because we need all these prerequisites in order to proceed. Okay, so if you are not familiar with those materials, please make sure you review. Okay, otherwise, for problems like this, you don't know what to do. Okay, so let's take a look at the denominator. And the idea and the concept we want to use from high school is called completing the square. Okay. We will talk more about completing the square in, I believe, 8.3. No, 8.4. Okay, we will talk more about completing the square in 8.4. Okay, but right here, okay, you learned this in high school, right? You learned this in high school. Okay, so let's do this directly. Remember the idea. The idea is to use a plus b quantity square. This is a square plus 2ab plus b square. Okay, so that means you need these 3 ingredients to make this meal. Okay, to make this dish. Okay, a squared plus 2ab plus b squared to make a perfect square. Okay, so right here, let me write this as x squared plus 2, 1x. And you might be wondering, why do I want 1x? Because we need a 2 times a times b right here. And apparently, right here, your a is x. Right, your a is x, so I have a squared. I already have a squared, check. Now I need a 2ab, and I have 2, x is a, so 2a. If I write 2x, I only have 2a, I don't have b. But if I write it as 2 times 1 times x, I know that my b is 1. So this is a squared, this is 2ab. And again, we need these 3 ingredients to make this dish. So we need a b squared. Okay, so we need a b squared. Okay, we need a b squared. Okay, now of course you cannot just add 1 right here, right? You cannot just add 1 to your problem. That will change the whole value. Okay, so you need to minus 1. Okay, but since we have 10 right here, that means we have 9 left. Okay, so you can see that this 1 plus 9 is 10. So I didn't change the value at all. Okay, but I need these 3 ingredients: a squared, 2ab, and b squared to make this dish a plus b quantity square. Okay, I need these 3. A plus b quantity square. And then I have plus 9. It's okay? So that means your integral will become 1 over x plus 1 squared plus 9. Okay, so apparently right here you need to let u be x plus 1. Okay, and du is just dx. Okay, du is just dx. Okay, so yeah, du is just dx. X plus 1 is your u. So this becomes 1 over u squared plus 9 du. And if you are familiar with Calc 1, you know that this integral will be 1/3 arctangent of u over 3. Okay. Okay. We can talk about that later. But right here, your u sub u equals x plus 1. Okay, u equals x plus 1. So you need to choose u. Not you need to choose C. I'm sorry. You need to choose C. Okay. Now for this, notice that if you have 1 over 1 plus w squared, and the integral of that will be arctangent of w. Okay, so the idea right here is to make this 1. So I can factor out 9. So this is 1 over, well, you can stop right here, okay, but let's just pretend this is a free response question and we want to finish this question. Okay, so this is how we proceed. We factor out a 9. So this becomes u over 3 quantity squared plus 1 du. Okay, so it looks like 1 over something squared plus 1, right? So you just need to use another u substitution. You got w equals u over 3. Then this will become 1 over w squared plus 1, and then you can proceed. Okay, so that's the idea. Remember, you want this to be 1, and how do I do that? I cannot just erase this and change my problem, right? I need to factor it out. Okay, so I factor it out from denominator. I also need to factor 9 out from u squared. So that's why I have u over 3 quantity squared. Okay, then use another u substitution. Okay, so there are more practice problems on Canvas. Again, please make sure you practice those problems. Okay, as you can see, there are these problems are just u substitution. Okay, but we have a lot of variations. The first one, you need to multiply both top and bottom by the same thing to create your du. Okay, otherwise you have 1 on top. There's nothing you can do. Okay, unless you multiply both top and bottom by e to the x. Okay, the second one, we factor out x because x combined with dx is my du. Okay, I really need to reserve 1x to make my du. Okay, and then I think of some other ways to change whatever is left. Okay, and the third example, we try to split up the fractions because right here we will use 2 different u substitutions. Okay, and the key point right here is that if your u is quadratic, then your du will be linear. If your u is linear, then your du will be a constant. Okay, and finally, we just use what we talked about previously. Okay, to understand that our u needs to be linear instead of quadratic. Okay, and once we know that, we need to change the denominator. And the way we change the denominator is to use completing the square. Okay. Now, if you have any questions, please do not hesitate to email me. Thank you.